By the end of this video, you will be able to read, write, and debug common loop patterns. You'll learn how to repeat actions, process various collections like lists, build counters, and choose the right loop type for the problem at hand. Loops are a fundamental part of Python's control flow. While variables store information and conditionals choose paths, loops allow us to repeat a block of code until a specific condition is met, helping to keep our programs efficient. Why do we need loops? Without them, we would have to copy and paste code, which makes it slower to write and much harder to maintain. Loops allow us to express a pattern once, while the computer handles the repetition. Here is a simple mental model for a loop. Start with a rule, run the body of code, update your condition or value, and then repeat until the rule is fully satisfied. It's a cycle of action and checking. A for loop is perfect when you know the collection or the number of times you need to repeat an action. Remember that the keyword is for. The loop variable updates every round, and the colon starts the indented block. Let's break down the anatomy of a for loop. You have the for statement, a temporary variable to hold the current item, the quote in keyword pointing to your sequence, and the indented body containing the code you want to repeat. Indentation is critical in Python. It tells the computer exactly which lines belong inside the loop. The standard practice is to use 4 spaces. Code that is unindented will run only after the loop has completed. To generate sequences of numbers for your loops, you'll use the range function. Range 5, for instance, provides numbers from 0 up to, but not including, 5. It's a very common tool for counting. You can customize range further by providing a start and a stop value. For example, range 1, 6 will give you numbers 1 through 5, which is often more intuitive for human-friendly counting. You can even control the step size. Adding a third argument lets you skip numbers, such as using 2 to count only even numbers, or using a negative number to count backward. Just remember that a 0 step is not allowed. Time for some practice. Try writing a loop to count to 5, then another to count only even numbers, and finally, one that counts backward. This will help reinforce your understanding of for and while loops. Looping through lists is a standard Python task. Since a list stores multiple values, your loop variable will pick up each one at a time. This keeps your code clean and avoids needing complex index references. When naming your loop variables, try to be clear. Use singular names for the individual items and plural names for the collection itself. This simple habit makes your code much more readable and easier to debug later. Finally, loops are great for building new data. You can start with an empty list, loop through your original collection, transform the values, and then append those results into your new list for later use. Now let's look at the accumulator pattern. This is a common technique where you maintain a running result as your loop progresses. You simply create a variable before the loop, update it with each iteration, and use the total once the loop finishes. A practical example of this is calculating a running total for a shopping cart. By starting your total at 0 and adding each price during the loop, you can easily track the final amount spent by the time you reach the end. Counters are a specific type of accumulator. Instead of adding a value, you add one for every item that satisfies a condition. This is perfect for searching through data or generating simple reports based on specific criteria. Remember that strings are sequences too. You can loop through them one character at a time. This is very useful for text analysis, such as counting how many times a particular letter or punctuation mark appears in a piece of text. By combining loops with conditional if statements, you can create character filters. This allows you to process specific parts of a string, like counting vowels while ignoring consonants, which is a great exercise for beginner programmers. Sometimes, you need both the index and the value while looping. The enumerate function handles this gracefully. It gives you a clean way to access the position of each item without needing to manually manage a separate counter variable. In Python, it's generally best to loop over values directly unless the position is strictly necessary. Using quote enumerate strikes a good balance when you need both, keeping your code cleaner and more Pythonic than managing manual index counters. When dealing with dictionaries, you can loop through the key-value pairs directly. The items method provides both the key and the value at once, which is incredibly useful for lookup tables or displaying clear labeled reports. Depending on your goal, you have options. Use keys to loop through labels, values to process the data itself, or items when you need to access both the label and its corresponding data simultaneously. Nested loops are essentially loops inside of other loops. While powerful, they can quickly become complex, so always aim to keep your logic clear. They are particularly useful for working with grid-based or multidimensional data structures. Think of a nested loop in terms of rows and columns. The outer loop selects your row, and the inner loop iterates through every column in that row. This pattern is the foundational building block for constructing tables. You should use nested loops when your problem has multiple layers, such as comparing every item against every other item, or when you need to perform calculations that span across a coordinate system. Switching gears, let's revisit while loops. Unlike for loops that iterate over a set collection, while loops repeat as long as a specified condition remains true. It's ideal for situations where you don't know the exact count in advance. The anatomy of a while loop is straightforward but requires care. You check the condition first, run the body, and most importantly, you must ensure something changes inside the loop to eventually make the condition false. A classic example is a countdown. You set an initial value and repeatedly subtract 1 until you reach your limit. It's a great way to see how the condition state drives the loop toward a natural, controlled conclusion. We must be cautious of infinite loops, which occur when the condition never becomes false. Always ensure your loop variable is updated within the block. And remember, you can use Ctrl+C to force stop any runaway code in your terminal. Sentinel loops are a clever use of while logic. They rely on a specific sentinel value, like quit or done, that the user enters to signal that they are ready for the loop to stop. Input validation is another common while loop application. By asking for user input and checking it against your criteria, you can repeatedly prompt the user until they provide a valid response, ensuring your program receives clean data. Sometimes, you need to exit a loop early before the standard condition is met. The break statement is your tool for this. It immediately jumps out of the innermost loop, allowing for efficient early exits. The continue statement, by contrast, doesn't exit the loop. Instead, it skips the remainder of the current iteration and jumps straight back to the start for the next round. It's perfect for skipping specific, unwanted items. When you need a temporary placeholder where code will go later, use pass. It does absolutely nothing but keeps the syntax valid. Remember to remove these placeholders once you're ready to write your actual logic. So should you use a for or while loop? If the sequence is known, like a range or a list, use for. If you're waiting for a condition that could change at an uncertain time, while is the way to go. Watch out for indentation errors. Python uses whitespace to define scope. If a line is indented incorrectly, it might execute when it shouldn't, lead to logic errors, or trigger a crash. Another common pitfall is the off by 1 error. Since Python's range function excludes the stop value, it is easy to assume a loop goes one step further than it actually does. Always test with small values to verify your count. Be careful when changing a list while you are looping over it. Removing items inside a loop can confuse Python, leading to skipped values. It's safer to build a new list or loop over a copy of the original. List comprehensions offer a compact way to perform loop operations. While they make code look elegant, prioritize clarity. If the logic is complicated, a traditional loop is much easier for others to read and maintain. You can add conditional if filters directly into list comprehensions. This allows you to combine transforming your data and filtering it in a single line. It is a powerful, concise syntax for standard list processing. When a loop isn't working as expected, trace it. This simply means watching your variables change throughout every iteration. You can use print statements to reveal exactly what's happening at each step. To trace effectively, use a trace table. Create a column for every variable and a row for every cycle through your loop. This visual approach is a classic technique to hunt down elusive logic error. Finally, remember that loops are about solving real-world problems. Whether it's adding up grocery prices or analyzing data, mastering loops gives you the power to automate repetitive tasks and write professional, efficient code.